Hey everybody, I decided to try something different this time and I put my video of myself onto the presentation. So we'll see if you guys like it. So let me know, give me some feedback on that. So we're going to finish up Unit 3 with these notes. So we're going to be talking about climate, weather, and the atmosphere. So we're not going to be talking about the traditional weather events that you guys think about, like tornadoes and blizzards. We're going to look at one that isn't really talked about a ton, and that's El Nino and La Nina. Before we get there, though, we need to understand the difference between climate and weather. All right, so if we look at our notes over here, what is the difference between weather and climate? So these images right here would be examples of weather. So you have clouds, thunderstorms, snow, rain. Keep in mind that these are all temporary conditions. They're not permanent, long-lasting. So weather is going to be short-term. These are short-term conditions in the atmosphere. Okay? Now, climate, on the other hand, is going to be a longer lasting situation. If I were to ask you guys, what's the climate of the tropical rainforest, you could probably tell me it's hot, it's humid, and it rains a lot. So, these are going to be examples of climate. And climate is what we attribute to ecosystems. So, climate is going to be long-term conditions, and they are in different regions of the world, obviously because we have different ecosystems. And so we typically are going to describe these in reference to biomes. Okay, now weather and climate are affected by basically what's happening in the atmosphere. So the atmosphere is then going to be affected by sunlight. All right? So this picture right here is showing us global air circulation, which is really important when it comes to climate and weather. So we're going to title this Global Air Circulation. Now hopefully you guys remember the difference between the northern and the southern hemisphere. So we're going to be divided in half by this line right here. So that's the equator, right? So if you look at the arrows on the globe itself, you can see that air circulates very differently in both hemispheres. And when we get to the Coriolis effect shortly, it's going to explain why hurricanes turn different directions. And, when the toilet flushes, it flushes one way in the northern hemisphere and a different way in the southern hemisphere. All right? So, at the equator right here, we have the greatest input of sunlight. So, ecosystems, cities, locations that are on the equator are going to be the warmest because they have the most direct sunlight. So you're going to see things like tropical rainforests and deserts in these locations. Okay, so you can see right here in these little boxes. Air cools and descends at lower altitudes. Warm air rises. Now, this is basic physics, guys. And I know some of you are like, oh my gosh, AP Physics, what? I thought we were done with this. But it is relevant to what we're talking about right now. So if you think back to physics, we know that when air is cold, it sinks. And when air is warm, it rises. And the same thing is true in general on the planet itself. Okay? So, cold air is more dense. That's why it sinks. So cold air is more dense. okay, and it descends. I'm circling this word right here. Descends or sinks, okay? Warm air is less dense. So warm air is less dense, so it rises or moves upward. So right here, moves toward the poles, okay? Now, by looking at this, we can say that heat rises from the equator, all right? So heat rises from the equator. And the reason the air moves like this is because the rotation of the Earth deflects movements. You know that the Earth rotates, and y'all, there is no such thing as a flat Earth, so just get that out of your head. The rotation of the Earth is what causes different patterns of air movement. So when we look at these arrows right here, okay, I'm going to draw an arrow down here, so we've got two. All right, so the rotation of the Earth deflects air into different areas. We're going to look at this in a little bit more detail in a few minutes. So it deflects air into different areas. Okay, so move on to the next page. All right, so what a lot of people don't realize is the air also directly impacts the ocean, which is going to contribute to the way currents flow in the ocean. Okay, so air right above the water, the temperature of that air will directly impact what's happening in the water underneath. All right, so if we look at this picture right here, you can see that we have a major current system on the planet. So these are all of our oceans. You can see that the water is going to flow in a cool and warm pattern. Okay, so if you follow the arrows, it shows you which way the currents move. So these are global water currents. Okay, so if you look right here, you can see that, look, the warm water is going up and the cooler water is going down, the same way air moves. It's the same concept, all right? So air also affects ocean currents. Okay, it also affects ocean currents. And the reason we need this is to distribute heat. We can't have oceans staying cold all the time or hot all the time. It's important for currents to move so that the nutrients and the sediments also move, because that's what a lot of sea life depends on for food. Okay, so cold water sinks, just like cold air does. Cold water sinks and creates a loop. Of interconnected currents. Okay, now this current right here is especially important because it directly impacts the United States. We'll talk more about this later, but if this current were to stop moving, it would cause the United States and Europe to go into another ice age. Hopefully that's not going to happen. All right, so let's look at how we can describe air movement. Okay, so this is a picture showing you the movement of air in the atmosphere. It's important that you understand how this happens, and you're going to see this theme being repeated multiple times in this unit. Okay, so let's start here at the bottom. All right, so when air gets hot, it rises. So the hot air goes up. Okay? When it reaches the upper atmosphere, it condenses and precipitates. Okay? Now, when it condenses and precipitates, it releases heat. Okay? So when these clouds produce rain, heat is also released into the atmosphere. So there's an effect from that. If it loses all of the heat, what happens to the temperature? It gets cold, right? So once the heat is gone, it now has become cool, dry air. And what do we know about cold air? What does it do, y'all? Yeah, you guessed it. It sinks. When it gets back to the bottom, it heats up again. It absorbs more of that heat. And guess what? It's a cycle, y'all. All right? Gets hot again, rises because it's hot, produces precipitation, loses heat, cools down, drops, all over again. Okay? So this is actually happening in the ocean as well. So the ocean and the air above it are directly connected to each other. So ocean and atmosphere are closely linked. All right? Like we said before, parentheses, ocean currents are affected by wind. Okay? So, this creates a cycle or a current. We call this a convection current. All right? So it creates a convection current. All right? And this can produce precipitation. All right, so this right here is our convection current. This loop that I just talked about, how air gets warm, it rises, produces rain, cools off, drops, gets hot again, cycle goes over. Okay? All right. Now, down here, this is basically showing on the Earth, we have 6 giant convection currents. And these 6 giant convection currents, we have 3 above the equator and 3 below the equator. And the way that this air circulates is what's causing these convection currents are leading to the production of biomes, which we're going to be talking about in Unit 4. All right, so I'm going to stop right here, and we will pick up the continuation of this unit in the next video.